Hello, Calculus student. This video is chapter 4.4 Mean Value Theorem part 2. So in part 1 we talked about how to prove it, what is it about, but I forgot something that is very important, like graphic. We talk about it like algebraically, but I think I should just draw pictures of what happened. So I have an interval. Does not necessarily have to be positive, but it's A and B. And then somehow you have f of A is this one and f of B is this one. So then you would have them like go up and down here. But if you draw a second line, that's connect them. There is a slope here, right? So this slope is m. What happened is mean value theorem say over here, any of these points there must be one. You can search through in here. There must be one C such that if I do a secant line, let's say which one look like this. This one maybe. If I do a tangent line, not secant line, so that the slope is f prime of C, I must be able to find this C such that it is in AB, and then this tangent line slope f prime of C is exactly the slope of M here. So that is what it is about. I think it's better to explain with a picture. The book also had a very good picture. So we did an example here to verify that, I can find a C that would actually have the same tangent line slope as the secant line slope. So let's do C. So this function is sine pi x. We know it's continuous, it's differentiable. This is closed interval. From 0 to, we want to find that it satisfies a mean value theorem. So to do that, we always want to find m first, the slope between 0 and 2. So f of 2, so that means sine, plug in 2, so it'll be 2 pi minus sine 0 pi over 2 minus 0. So sine 2 pi is 0, sine is 0, so it is 0 over 2, so that's equal to 0. And then we said that mean value theorems guarantee that there is a f prime of something that would actually equal to 0. So let's see, what is f prime? F prime of x is, do a derivative of the original function. Using chain rule, it would be pi cosine pi x. Mean value theorem say, guarantee what? There must be f prime of c such that it is or equal to 0, equal to pi cosine pi x. It is 0 because this one is 0. So can I solve this? Well, actually, it is solvable. That just means cosine pi x is equal to 0. When can this equal to 0? When the inside pi x is equal to pi over 2. Or when is it 0? Or 3 pi over 2. So let's just get 1 because MVT said that there is 1. So if that is the case, that means x is equal to 1/2. Right? So it's solvable. Last things to guarantee is it's actually in 0. Okay, open. It's actually in 0 too. So you can solve it and actually is in 0 too. So that verify MVT. The next one, verify that mean value theorem apply for y equal to ln x plus 1 in 0 2 again. So how do I do this? Again, do the m first. Slope is ln of 2 plus 1 minus f of a, f of b, ln of 1, 0 plus 1 over, maybe also 0 plus 1, so you know that we are plugging in them, over 2 minus 0. Okay, y2 minus y1, x2 minus x1. So it'll be ln 3 minus ln 1. ln 1 is 0 over 2. So it's ln 3 over 2. So this is the slope. And what does MVT say? MVT say if you do f prime of x of this function, remember how to do log ln of 1 over 1 plus x. Derivative is 1 over x plus 1 times the derivative of this, which is just 1, right? So that is equal to 1 over x plus 1. Mean value theorem guarantee that what? 1 over c plus 1 equal to ln 3 over 2 must be solvable. You can guarantee that you can solve it. So let's turn it over. That means c plus 1 is equal to ln 3. No, it's equal to 2 over ln 3. Right? And then what is c then? C would equal to 2 over ln 3 minus 1. So what would it be? If we put in the calculator, 2 over ln 3, it will be 1 point something minus 1. It's 0.8205. 0.8205. Is it between 0 and 2? It is between 0 and 2. So MVT, mean value theorem apply. So what does it guarantee that it apply? Remember, it has to be continuous in the closed interval and differentiable over the open interval. Okay, so we would have two questions where we would say mean value theorem does not apply, may not be applied because it does not satisfy both of the situation or one of them. So let's say I have my function x plus 6 over x minus 1 in the interval -3 to 3. It may not apply. Mean value theorem does not apply. So let's check. Is it continuous from f -3 to 3? No. There is a denominator x minus 1. X equal to 1 is not continuous. In chapter 2, remember? This is undefined. If it is undefined, it is not continuous. And so MVT does not apply. You may not solve anything if you find a second line between them. This one, the next one, y is the absolute value of x plus 6 on the interval -7, 0. So we know that this is a absolute value function, and also it's shift to the left by 6. So it's kind of like a V-shaped graph like this at -6, right? So at -6 is not differentiable, right? At x equal to -6, because it's a corner, it's not differentiable. So which is in your interval of -7, 0. So MVT does not apply. It has to be continuous as well as differentiable. So look out for these things. The last one is square root of absolute value of x. I don't know if you know how to graph it. It's actually graphing square root x left and right because you absolute it. So even if it's negative, I can now graph this at x equal to 0. It is not differentiable, right? So it's a corner, not differentiable. Whenever there's sharp corner like castles or not different, cannot write. So MVT does not apply. May not apply. Well, actually does not apply. If you want to use MVT, it has to be differentiable. This point is not differentiable. Okay, so the last part is mean value theorem and velocity. So this is something that is really useful. It's about, how do you tell if someone is speeding? So this terms, if s of t is a position function, s of b minus f of a over b minus a, it was slope, but it's actually a average velocity over the interval closed interval a b. So due to MVTs, we would say there must be a velocity, instantaneous velocity that is equal to this average velocity. So if someone claimed that they are not speeding because you cannot see them, because at the end they are not speeding, you can find the average velocity, and if the average velocity is actually like a speeding velocity, you can guarantee that during that trip there must be a speed that is exactly equal to this average velocity. And if this average velocity exceeds the speeding limit, that means that person has exceed the speeding limit at least once. Okay, so that's all about mean value theorem.